Let's look at a second example. Here we have a graph that increases then decreases. So the kind of function is a quadratic function. On what interval or intervals is the function increasing? Well, it seems to be increasing from negative infinity all the way up to the value x equals 3. And then it decreases from x equals 3 out to positive infinity. Which way is the graph concave? Well, this graph is concave down across its entire domain. Something that might model this function, or this function might model, would be anything that we throw in the air, like a football or a baseball. Any projectile follows a quadratic or parabolic path. To find the particular equation for the function, given that we have the points 176, 289, and 394, we're going to follow the same approach we did in the last example, where we'll start with the general equation for a quadratic function. So y equals ax squared plus bx plus c. And we're going to plug in our values for x and y and come up with three separate equations. So when y equals 76, I get 1a plus 1b plus c, plugging in the value x equals 1 into our equation. Now y is going to equal 89 when I plug in the value x equals 2. So 2 squared times a gives me 4a plus 2 times b plus c. Our third point, 3 comma 94, yields the equation 94 equals a times 3 squared, so 9a, plus b times 3, so 3b, plus c. As you can see here, I now have three equations with three unknowns, which we could solve by hand, but there's a much faster way to solve this using our calculator and using matrices. To solve a problem using matrices, we need to look at our system of equations here and recognize that we have inherent in the system some matrices. On the right-hand side of our equal sign, we have a matrix formed by the coefficients on each of our unknowns a, b, and c. If I wrote out those coefficients for each line, I could see that I've got a 3-row by 3-column matrix, where my first row would be 1, 1, 1, and my second row would be the coefficients 4, 2, 1, and my third row would be the coefficients 9, 3, 1, forming a 3 by 3 matrix. On the left side of my equation, I have three numbers in one column. So here my matrix would look like 76, 89, 94, forming a 1 or a 3 by 1 matrix. To solve for my unknowns a, b, and c, I need to enter these two matrices into my calculator, then multiply the inverse of the coefficient matrix by my y matrix. So let's pull up our calculators, go into our matrix menu, which is second x to the negative 1, and then I'm going to edit my first matrix. I'll choose that to be A. And I want the dimensions of this matrix to be 3 rows and 3 columns. After I hit enter, it's going to bring me down into the matrix, and I'm going to enter those numbers just as I have them over here. So 1 in the first spot, over to 1 again, and 1 again in the first row. And the second row is 4, 2, 1. The third row being 9, 3, 1. Now I have matrix A. Now to get in and create matrix B, I need to get out of here, go back into my matrix menu, go over to edit, and now I'm going down to B, and I'm going to create a 3-row, 1-column matrix. And those values were 76, 89, and 94. Now to find my values for A, B, and C, my unknowns, I need to take my first matrix, so I need to go back into my matrix menu and choose matrix A under names. And that'll bring that out. But I want the inverse of that matrix, so I'll raise that to the -1. And then I'm going to multiply it by matrix B. So I find matrix B in the matrix menu under names, 2. And then if I hit enter, I get my values in the form of a matrix for A, B, and C. So as you can see, our values for A, my value for A is -4, my value for B is 25, and my value for C is 55. So my equation would be y equals -4x squared plus 25x plus 55.